Starting off in geometry, we look at the basics of geometry. We define some things and name some things. So section 1.1, we're looking at points, lines, and planes. Our essential question is, how can you visualize geometric concepts? The first concept that we're looking at is a point. A point has no dimension and is represented by a dot. So here we have point A, right? That would be representing something. If I'm naming that, I'm going to show this on a separate sheet of paper just because of name of, I would say point A, or we could do a dot in front of it and an A. So those would be my two ways to name point A. Then we have a line. A line has one dimension, which is normally called length, and is represented by a line with two arrowheads. So here you have point A and point B, and we have the line there. This right here is a little cursive L. Okay? So when we're naming a line, right, since I had points A and B there, we can name that line AB, and the order of those letters do not matter. I can do AB with a line over it. Right, you need the arrows there. We'll deal with some other things later where we don't have the arrows. A line has to have the arrows. And if you have that lowercase letter, like the L, we can have line L. All right, but that only is if you have the lowercase cursive letter on the end of it. Normally we would use these two. Again, the order of these doesn't matter, and it will always be 2 points. So no matter how many points you have on the line, you only use 2 when you're naming it. Then we have a plane. A plane has 2 dimensions and is represented by a flat surface. Right, so we see that there. Right, we have 2 ways to name planes. Right, here we see A, B, and C as points. So one way to name that would be, we're going to do this above it, would be plane ABC. Okay, those points have to be non-collinear, which we'll talk about in a little bit. The other thing you can do is use one letter that's normally put in a corner and does not have a point. So I could also call this plane M. Okay. M is not a point. If you look here, there's no dot, so M is not a point. That's why I can call it plane M. If I'm using something with a dot, there has to be 3 of them. Some additional terms: collinear. Those are points that lie on the same line. Okay, so A, C, and B here lie on the same line. Those are collinear. So they're on the same line, and it helps some people to see I have a line right there in the word. Okay, so collinear. Non-collinear, points not on the same line. So A, C, B are collinear, but if I include D in there, that is non-collinear. They are not on the same line. Any 2 points have to be collinear. If you have more than 2 points, then it depends on where they're placed. Similarly, with coplanar and non-coplanar. Okay, coplanar, points that lie in the same plane. Now we're missing the E, but again, we have the word plane right in there. So coplanar points are on the same plane. Non-coplanar points not in the same plane. Okay, and most of the things we deal with will be on a flat surface. So you're sort of showing something that's off there. Okay, you're thinking of something that is not in that same flat surface. So if I was looking at the paper, something above the paper would be non-coplanar. Okay. And then we have a line segment. Okay. A line segment is part of a line that consists of 2 points called the endpoints and the line in between. So if I'm naming my line segment, here we have points A and B. So I can write out line segment AB if I want, right? But we can also do AB with a bar over it. Okay, so the line, oops, can't see that. Right? AB with a bar over it, That is our line segment. If I have the arrows, it's a line. If it doesn't have arrows, it's a line segment, and that means it ends. When I'm naming a line segment, I have to use the endpoints. So if I have a line here with A, B, and C on it, right, I can name that with a line with any of those, with any pairs of those. I go to A, B, B, C, A, C when I'm naming the line. But if I want the line segment, I need to look at where I'm starting and where I'm stopping. So if I want this line segment, that is only AC or CA. The order does not matter. Okay, but I can only use the two, and it has to be where I'm stopping for the line segment. Okay, so then flipping over, right, part of a line that consists of an endpoint and a line to the right or left is a ray. So the ray starts at one point, call this R, and goes forever in another direction. We'll call that Y. Okay. When I'm naming the ray, I always start at the end point. So I would name this R, then I would go where it goes. There's more than one point out here I can pick. And my arrow here always goes, the arrow when I'm naming it always goes left to right. It doesn't matter which direction the ray is. If I'm naming the ray, the arrow goes left to right. And I always use two letters. And here you have the one arrow. Okay. Rays that have a common endpoint and go opposite ways. So you have 3 points on the same line. Those are opposite rays. They would look like a line. You just have 3 points there. Right? And the set of points that figures have in common is an intersection, which should be a term you're familiar with. Just like streets intersect, our lines can intersect, and our planes can intersect. The key thing to realize here, most people are fine with this part. Two lines intersect at a point. If I draw two lines, they intersect at a point. But two planes intersect in a line. If you think of a wall and the floor, there's not one single point where they meet. It's the entire base of the wall, and that is a line. So then we're going to look at naming some things in our examples here. Okay, so example 1, we have the figure here, and we're going to use that to name some things. So it says give 3 names for the given plane. So I want 3 points that are not on, don't share a line and are on this plane. Right? So one name for that would be plane MVN. Okay. Now, A here doesn't have a point on it. That means I could also name this plane A. That's the only way I can name it with one letter. Right? And then I could look for other things that are on here. M, N, and P are on the same line, so I can't use all 3 of those. But I could do something like I could change this one and do MVP. Okay. And that would be our 3 different names for the plane. And there's other ways you can do those. And again, the order of the letters don't matter. The next one says name 3 points that are collinear. Okay, so these are points that are on the same line. So we have 2 lines here. We have this line and this line. There's 3 points on both of them. So either one would work. So either I could say MNP, or I could say TNW. You don't need both. It only asks for 3, but those would be my 2 possible answers. Again, the order wouldn't matter. Okay. Name 3 points that are coplanar. This is actually a bad question. Any 3 points that are always going to be coplanar, just like any 2 points are collinear. But what they're probably looking for is 3 points in this flat surface here. So we'll say M, V, and N are coplanar. Right? But any 3 points you name there have to be coplanar because 3 points define a plane. Name a ray and a line segment. So I'll look at this here. Okay, my ray I'm going to call NT. I start at N, I go up towards T. Looking at this line, I'm going to call that line TW. Okay, there's a bunch of ways I could name those. There's a ton of other things I could name here. Any point that, and then when I go in a different direction, that would be a ray. I can use any 2 points to name a line. Oh, actually it says line segment. That'd be wrong because that's not a line segment. That's a line. This says segment. So then if I'm using TW, I would have to stop at T and W. So I would want the bar over that. Okay. Then looking at example 2. Give another name for VX. And that is a line segment. So the only other way I could name that would be XV. I can't use W, even though it's in there, because it's a line segment. If it was a line, I could. Name all rays with an endpoint W. All right, so WY, WZ, WX, WV. All right, and the ones that make up the same line would be opposite. So I would have WY as one, WZ as another, and those would be opposite rays. Then I would have WV as one, and WX as another, and those would be opposite rays. We have one more page to do, but then the last question on this page says, are VX and XV the same ray? And then are VW and VX the same ray? So VX and XV, they start at different points. So this has to be no because of the starting point. The same ray would have to start at the same point. VW and VX, that would be yes, because they both start at V and go in this direction. So that would be why those are opposite rays. Okay. A couple things on sketching here. All right, sketching your ray is easy. TS, you just start a point, name that T, draw an arrow, put a point on there, label that S. Doesn't matter what direction you go to. Two planes that intersect in a line. Okay, do your best to draw, if you're trying to draw this, what it should look like is this picture down here. Okay, I can't really draw that. I'm going to show that I have something coming out here, and I have something coming up here, and that's where they're meeting. All right, you're showing the concept, even if it's not a great picture. And then sketch two different lines that intersect a plane at different points. So I'd have a box that represents my plane. I have a line and a point that represents hitting it, and another line and a point that represents hitting it. All right, that would be my sketches. All right, so we're not looking for a lot from the sketches, just something that would illustrate it. And then our final thing, name the intersection of planes C and D. Intersection of a plane should always be a line. So I'm looking at this line here. There's only one point they show me on that, so I have to name that line A.